Hello everyone, a very warm welcome to this video. In this video we are going to talk about cluster planning. So let's understand what exactly is cluster planning. Now we understand how a Hadoop cluster works, but if I'm starting a new project, where do I really start with? How do I calculate the size of my cluster? How should the whole thing work like? So let's look at that in this particular video. So the agenda of this particular chapter is cluster planning. Here we are first going to talk about sizing of the cluster. What should be the size of my cluster? How should I plan for that? Next thing we will see is the hardware. What should I buy for slave and what should I buy for the master? We talk about operating system. We then talk about the Java version. We talk about Hadoop version. We talk about a few parameters that could be there in BIOS. What about the network? So this is the agenda of this particular video. In this video, by the end of this video, you'll be very clear with what is that you should do for your Hadoop project. What is that you should do for your Hadoop project? So let's get going. So the first thing is, how do I decide size of my cluster? How do I decide size of my cluster? So let's say when we start a project, we are planning for 1 year. We are planning for 1 year. So the first important information that you require is your incoming data. Let's say our incoming data is 3 terabytes per week. So every week what we get from our customers is 3 terabytes. Now 3 terabyte multiplied by 3, that's a replication factor, turns out to be 9 terabyte. So 3 multiplied by 3 is 9. So per week, if a customer is pushing 3 terabytes to us, 3 multiplied by 3 would turn out to be 9. And we would also want to have 3 terabyte for operating system and mapper phase output, because mapper phase output is written on local file system. So typically on a machine, 75% is HDFS and 25% is local file system. So just to bring everything together, for incoming data of 3 terabyte, we need 12 terabyte of storage per week. So if every week we are getting 3 terabyte of incoming data, 3 multiplied by 3 is 9 plus 3 terabyte for OS and other stuff, which will turn out to be 12. So per week we require 12 terabyte of data. If a single machine that we buy in our data center is 24 TB, each machine that we buy is 24 TB, we would need a new machine every 2 weeks. 3 terabytes of incoming data, 3 multiplied by 3 is 9 plus 3 is 12. So every week we require 12 terabytes of storage. If every machine we buy is 24 terabyte, every 2 weeks we'll require one machine. That means end of the year we will need 26 slaves. We will need 26 slaves and we will have around 650 terabyte of data. That is how you define, or that is how you decide the capacity of your cluster. So for first year, we will need 26 slaves and of course 4 masters. We saw that in the topology section. So if we were to plan a cluster for 2 years, we are looking at 56 machines or boxes. This is how you define the size of your cluster. So the first and the important thing to anticipate or be aware is the amount of incoming data that you are getting per week. Based on that, whatever you are getting per week, multiply that by technically by 3, so that's replication plus 25% add to that. So whatever you are getting per week, multiply that by 4. 3 is replication and 1 portion of it is operating system. Incoming data multiplied by 4 is your per week storage capacity required. If one machine is gonna be running for 2 weeks, let's just say, so basically in a year we will require 26 machines. For 2 years that will turn out to be 52 machines plus 4 machines for the master, one running name node, standby name node, resource manager and standby resource manager. So by the end of 2 years you will require 56 machines. Based on that, as a project manager, you will have to decide the capacity of your cluster. Based on that, as a project manager, you will have to decide the capacity of your cluster. This is how sizing is done in your cluster. This is how sizing is done in your cluster. Now that we are clear with how exactly we should decide the size of the cluster, let's talk about, if we know the size, but what are the configurations available in the market? What is that we are supposed to purchase or order from the procurement department for our cluster? So let's talk about what do we require for master and what do we require for slave. Along with that, we'll answer some questions about a few other topics pertaining to slave and master. So let's first talk about slave machines. When we are talking of slave machines, there are 2 types of configurations available in the market. One is called midline and another is called high end. So one is midline, another is high end. When we are talking of a midline machine, we are talking of 12 multiplied by 3 terabyte hard disks, around 64 GB of RAM and 2 into 6 CPU cores. Typically this is what would be called as a midline machine. Now when you order these machines, you don't have to go to a vendor like HP or Dell because that will cost you a lot of money, a lot of dollars. What you would want to do is you would want to assemble them yourself. This is also in the hardware market called as Intel white boxes. Intel white boxes are basically nothing but machines that are not really branded, typically assembled by your own IT. If you go for high end, you typically have 24 into 1 terabyte, 96 GB of RAM and 2 into 6 CPU. This is what you will have on the machine. This is what you will have on the machine. There are a couple of things you should take care of. Well, a good realistic hard disk is 36 terabyte. Beyond that, there would be issues. Let's say if a node fails, name node has to replicate that lost data. And if the machine lost was having very big hard disk or very large capacity hard disk, this will result in massive traffic towards balancing out or getting to 3 replication factor. So that's very important. So don't go for machines with a higher hard disk than 36. That's a good maximum. Second thing is RAM have as much RAM as possible. The idea is that few of our customers have 512 GB RAM on slaves. So new frameworks like Spark, they are very memory intensive, Spark or Impala. So basically the more the RAM, the better it is. When it comes to CPU, no need to invest in expensive CPU because Hadoop majorly works on network and disk I/O. So Hadoop's real performance, it depends on the network and the disk I/O. So investing in top of line CPU would not be a very good idea. When it comes to hard disk drives, more the disks, the better it is for parallelism. That's important. So the more disks you buy, the better it is going to be for parallelism of your system. And so this is all about RAM, CPU and hard disk of slave machines. Let's quickly talk about a few things from the cluster perspective. 3 topics that we are going to talk about is virtualization good? Are blade servers a good idea? And how about RAID? So let's look into those aspects right now. So the first question that arises in our mind is virtualization a good idea? Let's answer them here. So the first question is virtualization a good idea? Well, it's recommended that you don't use virtualization. The reason being, in virtualization, data locality is not really guaranteed. So your hard disk may be on a different machine and your operating system may be running on a different machine. That will incur penalty. Second thing is, in virtualization, the underlying hardware is completely abstracted. And because it's abstracted, what if all the 3 replications are sitting on the same underlying hardware, and if that hardware fails, it's going to be a problem for loss of data. So that's why it's recommended that if it's a serious cluster that you're going to use on the production side, deploying Hadoop on a dedicated cluster is completely recommended, or it's considered to be a very, very good idea. So virtualization is certainly going to have penalty. But if you're doing it for a POC, like what we are doing it for a lab, or if there are demonstrations that you want to carry out within your organizations, cloud is an incredible idea. But for real serious production deployments, cloud is something that's yet to really take off because of this locality issues. The next question would be that, can we use blade servers? What are blade servers? You get an entire cabinet where the machines are in. Blade servers are again not recommended because if a machine fails, it's going to be a problem, and network speed is also limited. So a good idea is not to use blade servers but independent machines. And third is RAID. So the question that may arise is, why are we using replication factor of 3? Why don't we use RAID? Well, the problem is, in RAID, your speed depends on the slowest disk. In RAID, invariably, your speed depends on the slowest disk. A lot of tests performed in various organizations, RAID performed 30% lesser than JBOD. JBOD is just a bunch of disks where the disks are not RAIDed, but they are independent and the data gets written. In our lab, what we are going to see is, when we are setting up our clusters, all our disks or folders are completely independent, or they're also called as JBOD, just bunch of disks. When you use just bunch of disks, you are guaranteed to have around 30% better performance than RAID. So when it comes to slaves, so we've kind of discussed everything that relates to slaves and the cluster. So let's quickly summarize what we've seen about the slaves. So in slaves there are two configurations available, midline, high end. We understood that any amount of RAM is welcome. We also understand that the more hard disks, the better it is for us. We also understand that more than 36 terabyte is a bad idea. We don't have to invest in CPU. We understood that virtualization is not a good idea. We also spoke about blade servers not being a good idea, and we also spoke about why JBOD is better than RAID. So these are all the considerations that you should have when you're talking of the slave machines. So a quick summarization would be, first we saw about cluster sizing. So whatever is your incoming data per week, multiply that by 4, that will give you the amount of storage required per week, and then decide on the size of each machine that you have and plan for 1 year or 2 years. Your sizing is done, but what kind of hardware you should be looking for? When you're talking of slaves, you should either go for a high end or midline. RAM as much as possible, hard disk maximum is around 36 terabyte. Expensive CPU is not required. Don't talk about don't go for virtualization blades or JBODs. Now let's shift our focus to the master machine. Let's shift our focus to the master machine. Now when it comes to master machine, what we are really talking about is don't buy machines that are cheap or commodity level. Get machines which have incredible SLA levels. Get machines which have incredible SLA levels. Typically 96 GB RAM, can be low on hard disk, can be. So can go for any be great. And the only thing important here is make sure that your name node is highly available. What exactly is high availability is covered in the high availability video, but here what we talk about is when it comes to master, get the best hardware which is out there. RAM is important, get 96 GB of RAM. Hard disk can be low, which is absolutely okay. When it comes to CPU, a normal machine would do. It's not really CPU intensive, but make sure that on name node high availability is configured. High availability is configured. So what we've seen so far, we've understood sizing of the cluster, hardware. In hardware, we've understood master and slave. Now let's quickly talk about the operating system. So first thing, there are no specific recommendations from the operating system perspective. There are no specific recommendations from the operating system perspective. Most commonly, Red Hat is used on master and CentOS is used on slaves. There are other operating systems like Ubuntu which are welcome to be used, or you can use SUSE which is very popular in Europe, But the point is there are no specific recommendations that any vendor makes when it comes to operating system, because either ways it's going to be performing exactly same way, because Hadoop really works on the user space and not on the Linux kernel as such. So what's most common in the industry is Red Hat is used on the master and CentOS is used on the slave. When it comes to the Java version, make sure that you use Java which is from Oracle, and don't go for latest but most stable. So when it comes to JDK, make sure you do that. So operating system side, there are no recommendations. Red Hat or CentOS is most common, but you're free to use Ubuntu or SUSE. When it comes to Java version, use Oracle's Java and make sure that you don't go for the latest, but you go for the most stable. The third recommendation is Hadoop. Preferably use Cloudera's distribution for Hadoop. And a good idea would be to use Cloudera Manager against manual setup. And choose version that's marked as production ready by Cloudera. So this is what you should have when you're talking of operating system, Java version and Hadoop. So these are a couple of recommendations on that side. So we've understood operating system, Java version and Hadoop. Let's quickly talk about network and BIOS. And let's talk about how would you do benchmarking of your Hadoop cluster. So there are a lot of optimizations that you can do on BIOS and OS. One of the most important, or two of the most important, QPI should be enabled in BIOS, and second, your U limit for maximum number of files should be 32,000 on OS. So the maximum number of files that can open on an operating system should be made to 32,000. So these are some things that you would do on the BIOS or OS side. So a quick recap of what we require from the environment perspective. From the operating system perspective, Red Hat and CentOS is most common, although there is no recommendation or recommended thing that needs to be done. When it comes to Java, Oracle is very popularly recommended. Don't go for latest, but for the most stable version that Oracle recommends. When it comes to Hadoop, use Cloudera's distribution for Hadoop. Preferably use Cloudera Manager against manual setup and choose version which is right now production ready. When it comes to BIOS and OS, there are a lot of optimizations that could be done. QPI should be enabled and U limit should be made to 32,000 on your operating system. The next thing we are going to talk about is network. Minimum is 1 gig. Good to have will be 10 gig, the bandwidth. And third thing, use always bonded Ethernet so that you don't have to really worry about failure, or at least you are protected against failure. And when you have racks should be connected via core switches. So when it comes to network, preferably go for 10 gigs bonded Ethernet. That will be the most common that you will be using, and that is something you can procure. So that kind of brings us to the end of the cluster planning part. Let's quickly understand the entire flow of it. So if a new project has to start for a customer, the first question would be what should be the size of the cluster, and we've seen that in this particular session. We've seen how to plan for 1 year or 2 years. The next question that needs to be answered is what should be the hardware configuration for slaves, hardware configuration for the masters, what should be the network, what should be the operating system, what should be the Java version, what should be the Hadoop version, what optimizations to be done on BIOS and OS. And we've also seen, or we also are aware that what not to consider at all. So no need to consider blades, RAID and virtualization. So that gives you an entire idea of if a new project was to start, what are the tick marks that you have to have before you start the project. The last topic that we will discuss in this video is called as benchmarking. So let's understand what exactly is benchmarking. So we've set up a new cluster, and how do we test performance of that particular cluster? We've set up a new cluster, and how do we test performance of that particular cluster? Well, there is an interesting benchmark that is available. So let's compare this benchmark with as good as mileage. So when a new car comes out, what you really want to do is you will want to test the mileage of the car, and that's one of the most important benchmark. Similarly, the benchmark to test the performance in Hadoop is called as TerraSort. TerraSort typically, let's say, would it's up to us how much data we generate, but let's say we generate 100 million lines of 100 bytes each, and then we sort it. So this is a ready-made benchmark available where you can generate X number of or N number of lines, N bytes each, and then you look for sorting it, and that will give you performance. So the way you test is before adding new nodes, run TerraSort and note down the time. After adding n new nodes, run TerraSort and note down the time. Now this would give you the performance gain by adding new nodes. The important note here is be sure of the other jobs that are running inside the cluster. So this concept is called as benchmarking your cluster, and the name of this benchmark is called as TerraSort. That's very popular. So in this video we saw how to define the size of, or how to decide the size of the cluster. We saw in terms of hardware what to buy for master and what to buy for slave, operating system, Java version, Hadoop version, BIOS, network, and benchmarking. So this was all about planning your Hadoop cluster, and this will give you a lot of valuable insights when you are starting your new project. Thanks for watching this video.